All right, welcome everyone to the beginning of chapter 15. We are finally done our voyage into trigonometry, and we're going to start up something called combinatorics in chapter 15. Okay, and our first section here, 15.1, I know you guys love the titles, but this is just going to be about Venn diagrams. I'm sure you guys have all had at least a little bit of experience with Venn diagrams in the past, but this is going to be maybe slightly different from what you've seen before. So let's just jump right into it. First of all, what is combinatorics? It's a branch of math that talks about counting. And when I'm talking about counting, I'm not saying, oh, great, 1, 2, 3, 4, I know how to count. Yeah, no, okay? What combinatorics is, well, that's definitely part of it, but what combinatorics is mainly about is kind of answering those type of questions. In how many ways can I do this? Like, how many ways can these 5 people sit in these 4 chairs? If the pizza shop has 3 pizzas and 6 cheesesteaks, how many different combinations of orders are there? Those kind of questions there. And that has a lot of importance, especially in things like probability. And also, those kind of questions come up all the time on like standardized tests. So I think the SAT has a lot of questions like that, I believe. So definitely important. All right. So let's jump right into Venn diagrams. The way we kind of work with Venn diagrams may be slightly different, but it's really not too bad. The first thing that we're going to do, so we're just going to build a Venn diagram here just using this information that I've written over here. And so the main difference with the Venn diagrams we're going to build is we're going to have a big rectangle around all of our Venn diagrams, and that's just going to refer to something called U, which is the universal set. And so the universal set is basically going to contain everything that we're interested in. So it's basically the total. In our case, that U is just the 1,000 typical Americans that we're discussing here. So I'll write my U, and that's that universal set. Okay, great. And so these portions, these circles inside of my universal set, those are going to be what we call subsets. Okay, and I mean, since we already have these letters defined here, I'll just call the people that have antigen A, I'll refer to them as the ones that are in set A. And the people that have antigen B, I'll refer to them as in set B. All right, and of course, those are not the letters you always have to use, so you use whatever letters make the most sense in the problem. Here, A and B are just kind of natural. All right, so if I want to kind of fill in the different portions of this Venn diagram, the first thing that I'm going to want to fill in is kind of this overlap section. We have 40 have both antigens, and that's going to correspond to this little middle section of the Venn diagram. Okay, so what I'm going to fill in there is I'm going to fill in 40. So those are the people that are in both set A and set B. All right, great. And then for set A, kind of this circle over here, it's going to look very intriguing just to throw in 450 right off the bat. But this circle, the portion that does not include this kind of overlap, this needs to be just A. And really we can think of it as A but not B. So to figure that out, we just need to do 450, the total in A, okay, minus the overlap there, okay, subtract out that 40, and we would get 410. And so that's going to be the number that are in that set A over there. All right, and we can do the same thing for B. So then we would just take the number that are in set B, which is 140, subtract out the 40, so we're left with 100, and that is the number that just have B. So that is B, but not A. Okay, so over in this section where we have 410, that is A but not B. In the middle here, that is A and B. Over here, this is B, not A. So let me just write that in here. Okay. In a typical Venn diagram, you'd be done. But for our usages, we also want to kind of fill in this area that's outside the circles. Okay, so that area outside the circles, that's going to represent the neither, the none of the above. So not A or B. Okay, so to figure that out, we have to take the total, that universal set 1000, and basically just subtract out the entire inner Venn diagram. So minus 410, minus 40, minus 100, which would give us 450. And those 450 people out there, that is representing not A and not B. So they have neither of those two antigens. All right. And let's kind of just get some more vocab here. So this first thing here, what I was referring to in the last slide is the overlap. That's going to be what we call an intersection. Okay, so if we have two sets A and B, the symbol for an intersection is this right here. Basically an upside down U. Okay, and that's going to be talking about an intersection. And the way you kind of think about that in English is you can think about it as A and B. Okay, so it needs to have both capabilities. In our previous example, it was a member of both sets. Okay, it was the people that had both types of antigens. This other thing we call a union. Okay, the symbol we denote that is if we have these two sets, A and B, this would be A union B. It's basically just denoted with a U. Okay, and what this is A or B, if you wanted to read that in English. Okay, so that basically includes the entire inner part of the Venn diagram, because people that are just A are included, people that have A and B, and people that are in just B. Okay, so intersection, is that upside down U, that's going to mean A and B. That's going to be the overlap. The union, okay, that's going to be A or B, represented with this big U. And that's going to be the entire inside portion of that Venn diagram. All right, another vocab word is the complement. Okay, so this is what I was referring to as basically when I was talking about not A. Okay, so it's referred to as not A, and the symbol used is A with a little bar on top. And this is, and if you're going to see this in English, it would just be A complement. Okay, and so if I was going to fill in this portion here, this Venn diagram I have here, if I wanted to fill in and shade the portions that are not A, if I wanted to shade A complement, it would be all this region over here. Wish they gave me a bigger, let's see if I can, oh well. But all that, the portion that is just B, that would be what we refer to as A complement, okay? Just B. Another thing we could do is, if we wanted to do, let's say we had A, okay, so that's going to be A union B, okay? So remember when we had A union B, that was the entire filled in Venn diagram, but this is A union B complement. So the complement of A union B is everything that is not inside the Venn diagram. So it's going to be all this outside area that would be shaded in there. Basically, the portion, if we're going back to that antigen example, it would be the portion that were the people that were members of neither set. That is, and that would be pronounced just A union B complement. Okay, this principle here is called the inclusion-exclusion principle. Okay, so you may have noticed that if we're trying to figure out, this N is just indicating the number. So if we were trying to figure out the number, oops, that's a terrible color. If we were trying to figure out the number that is in A union B, okay, you may have noticed that this does not just equal the number that is in A plus the number that's in B. Okay, because what would happen is you would double count this overlap portion right here. Okay, so what we need to use is, it's very straightforward. To figure out the number that is in A union B, okay, so the numbers at A or B, you take the number that are in set A plus the number that are in set B, and then subtract out the overlap, okay? That's that A intersection B, and that portion is you're just subtracting out the overlap. Because otherwise you will double count. The people that are in this set, the A intersection B, have already been accounted for, whether they were in set A or set B. Okay, so I'll show you an example of using this principle. All right, so first let's kind of really make sure we understand what all these symbols mean. All right, you notice that now I have kind of 3 Venn diagrams going. Okay, so this first one, let's just kind of fill in, shade in some different kind of sets here, so we know all these symbols and kind of get used to working with them. When we have the 3 Venn diagram situation, all right, everything still means the same. As you notice here, this B intersection C, so that's just the overlap of B and C. The portion in the middle is the members of all 3 sets. So let's, for this first one, let's do A intersection B complement. And let's make sure we add our outer rectangle as well. All right, so thinking about what A intersection B would look like, okay? So A intersection B, that is going to be the portions of our Venn diagram that have both A and B, okay? So that would be in this little sliver right here, okay? That would be the A intersection B, as well as the portion that has the C involved too, because that fits the A intersection B. However, since we're asking for, we have this bar over top, so we're asking for the complement of that. What we actually need to do is we need to shade in the entire rest of it. Okay, so everything except for that region that I just highlighted. So everything that is not A intersection B. So that includes things that are outside the Venn diagrams. That includes this just C. That includes the B intersection C. That includes just B. All of that. All right. Looks ugly, but I think you can get the idea. All right, let's try another one here. Let's do, for the second one, oops, pick a color you can see. So for the second one, let's do something. Okay, so here we have A intersection of B union C. Okay, so for that B union C, okay, that would be everything that is the B or C, okay? So that would be these entire two circles of B and C, okay? But we want the parts that also intersect with A, okay? So if this portion here, the B union C, okay? If that's going to be these circles, okay? And we strictly want the portions of those circles that have A involved. So A intersection with those, okay? So taking a look there, the portions that are in that circle that include the A are just going to be this little sliver right here, the overall middle, because that's going to be A intersected with that B union C, and then the A intersection C over here. Okay? Remember to pronounce this in English, it would be A and B or C. Okay? So it's anywhere where A overlaps with either B, C, or both. All right. Awesome. And then last one on this slide. I forgot to put the rectangle around this one. Didn't really affect our work. But I'll put a rectangle around our third one here. All right, and let's make this one B union A complement intersection C complement. All right, so you got to think about this. So remember, when the little bar on top, that means so A complement, C complement. So it means not A and not C. Okay, so that not A, not C. Okay, so we know it's definitely not going to include these portions where in this section here where it's just A, and these sections here where it's not C. Okay, but where it says, so it's B union, okay? So we know it's going to include everywhere where it has B or where it is not A or C, okay? So let's first kind of color in everywhere where it's going to have B. So everywhere where it has B is going to be all the B circle, including where it has A or C. Okay, those areas are fine because since it's B union those areas, or, okay, it's fine that it has A and C in those areas as long as it has B, which it does. What is going to be excluded is the areas that have just A, just C, or just A and C. Okay, so that whole circle there, that's going to be the B portion, and then that's union not A or not C. So what also needs to be included here is the outer portions, because those outer portions do not contain A or C. So that also needs to be shaded in as well. don't know why I was using my my mouse shading. It's a lot easier with my finger. All right, so there we go. So that will represent the B union of A complement intersection C complement. Okay, it does not include anywhere where it has just A or just C or A and C. Okay, but it includes anywhere where it has B or anywhere else, which is the whole outer region where it does not have A or C. All right, great. So this example, let's kind of work through some with just actual numbers here instead of just using those symbols, although we cannot forget those symbols. So this one is, so we have 450 seniors at Central High School. 335 are taking math. Okay, so I'll just call that set A here. 287 are taking science. I will refer to that as set B. You could use the letters M and S if you wanted. And then 220 are taking both. How many are taking neither math nor science? All right, so let's kind of just fill in a Venn diagram to represent this example first, and then we can kind of go through and fill in the corresponding, or answer the question after we filled in the Venn diagram. The first thing I'm going to fill in this Venn diagram is the overlap. We have this 220 are taking both math and science, so I'll fill that in right here. All right, and then I am going to use that kind of inclusion-exclusion principle, okay, to kind of get for my areas with A and just B. Okay, so my areas with just A is going to be the 335 total students who are taking math. Subtract out the overlap of 220. Okay, and so that would get me, sorry, 115. And that's the number that are just taking math, but not science. Do the same thing for set B. So this would be 287 minus the overlap of 220, which would get me the 67. And those are the people that are just taking just science. Since we're looking for neither math nor science, okay, what we want to do is what we're really looking for is this outer area, okay? The symbol behind that would be A union B complement, not A or B, okay? So what I'm going to do is just going to take my total, 540, all right, and subtract everything that I've got inside that Venn diagram. So it would be 540, subtracting out that entire Venn diagram, the 115, the 220, the 67, and you would get 138. That would be the section that is outside the Venn diagram, and that would be the number of students that are taking neither math nor science. I don't know what they're taking, but at this school, they are not taking math or science. All right, great. So hopefully that example is pretty basic. Let's try another one, another kind of two Venn diagram one. So of the first 100 positive integers, 25 are prime. Hopefully you remember what prime is. It means its only factors are 1 in itself. 9 are factors of 100, and 68 are neither prime nor a factor of 100. So once again, let's start. I'm just going to fill out the Venn diagram. All right, so this time they give us the neither. They give us that 68 are neither. So I'm going to fill in that section first. All right, I will refer to the prime ones as set A and the factors of 100 as set B here. Okay, but I can't fill in these sections yet. I can't just say, I can't write 25 here because that is the total number of prime. We don't know how many are in both yet, so we're gonna need to kind of figure that out first before I can kind of start putting that in for A. So let's try and answer, and we got to figure out part A, this how many are both prime and a factor of 100. That'll give us this overlap here. Okay, the way we can do that is, I know that the total Venn diagram, because I know that there's 100 total, and I know there's 68 that are neither. So 100 minus 68, that's 32. And so that 32, that's going to be the total number that are in the Venn diagram. Okay? In other words, that's going to be the number that are in A union B. And we can use that inclusion-exclusion principle. We know that's the number of A plus the number in B, subtracting out the overlap, A intersection B. Okay, and since we know most of these things, I know A union B, that's the entire Venn diagram, that's that 32, equals the number in A, that's the number of prime numbers, so that's 25. The number in B, that is going to be 9. And we're trying to solve for that intersection. We're trying to solve for that overlap. So I'll just call that X. Okay, so great. So 25 plus 9 is just 34. So that means that X equals 2. So 2 is the overlap, and that is the answer to part A here. Now I can quickly fill in the rest of my Venn diagram. I know there's 25 prime numbers, but I know 2 of them are also factors of 100. So 25 minus 2 means 23 are just prime. And then 9 minus 2 is 7. So the answer to part B, a factor of 100, but not prime, okay, that's just going to be, this is part A. Part B is just 7, the number that are just simply a member of set B, a factor of 100, but not prime. All right, last example. This PowerPoint's getting a bit long, but now I wanted to make sure we do a 3 Venn diagram example here. So we have 113 business executives. We're asked if they read the Wall Street Journal, Business Week, and Time. All right, so let's kind of start labeling our sets here. We have W, I'll call this B, and I'll call the time T. Let's kind of fill them in. And then I'll draw our outer ring as well. All right, and we have all the data over here. Okay, so the first thing that we can immediately fill in is the overlap. 42 read all 3. Okay. So let's kind of try and figure out how to fill in the rest of this Venn diagram. Okay, so basically filling in all of the circles, all the overlaps, and the outer portion. So for this section here, for the W, that's going to be the people that only read Wall Street Journal. So that's just 6. The 5 only read Business Week. So that would be this section here. And 8 only read Time Magazine. That's this section. All right, great. But we still have a lot of gaps in our knowledge here. We still don't know kind of how many read both Wall Street Journal and Business Week, but not Time. We don't know. So we don't know any of these other overlaps, and we don't know how many read none of the above. All right, so what we can do though is we can kind of set up a little system of equations here. So I know that 88 total read Wall Street Journal. So that 88 is going to be the total that is in this circle right here. All right, and I'm just going to kind of define some letters here. I'll call this A, I'll call this B, and I'll call this C. So based on that 88 that is inside that green circle there, that would be 88 has to equal 6 plus 42 plus A plus C. All right, or in other words, if I just subtract that 48 that's over here over, I know 40 equals A plus C. By the same logic, I can do the same thing with the Business Week one. I know that 76 read Business Week. So that's going to be this blue, the whole set B, representing this blue circle. So setting that up, it'd be 76 equals 5 plus 42 plus A plus B. So 76 minus 47, so we'd have 29 equals A plus B. All right, and then finally, we would have the 85 that read Time. That's going to represent that whole circle there. So we had 85 equals 8 plus 42 plus C plus B. And so just moving that 50 over, so that would just be 35 equals B plus C. All right, so what we would do here is we have this system of equations. We have 3 equations, 3 unknowns. We would just solve that system of equations. Okay. Due to time and space, I'm not going to solve a system of equations right here, but it's very easy. All you would do is just kind of do some substitution. I would just move the C over in this first equation. So I'd have like A equals 40 minus C. Substitute that into a different equation, and then kind of do combination from there. Okay, so I'll leave that work to you. But if you do solve all 3 equations, you end up getting A equals 17, B, that's an ugly B, B equals 12, and C equals 23. And so those would fill in those slots there for A, B, and C. And what those are representing for that 17, that's the people that read the Wall Street Journal and Business Week, but not Time Magazine. The 12, which is B, that is going to be here. That's the people that read Business Week and Time, but not Wall Street Journal. And C is 23, so that's this group. And the final value, the people that read none of these, okay? The way to get that is just to subtract everything from 113, okay? If you subtract everything, so it'd be minus all those numbers inside there, you end up getting 113 minus 113, which is 0. So in this group of business executives, 0 people read none of the above. Okay, so everyone reads at least one. All right, that's a solid 35-minute video, so I'll stop it here. There we go. Hope this was helpful.